Hello, I am Daniel Motzer. Today is June 29th, 2026, and I am making this YouTube video for my Artificial Intelligence assignment for ISAS 640 at UMGC. This week in class, each day was spent learning new information and further grasping lessons I have learned in the past 7 weeks on artificial intelligence and decision support systems usage. In the presentation, I will discuss AI and DSS, machine learning and data analytics, expert systems, ethics in AI and DSS, and best practices for designing and implementing AI and DSS. Additionally, I will provide uses and examples of positives and negatives associated with AI and DSS prior to concluding the presentation with an analysis of two real-world case studies. Early in the week, I solidified my understanding that AI is used to create machines that perform tasks which previously relied upon human intelligence. These tasks include learning, problem solving, and decision making. DSS are AI applications that assist in the task of decision making. DSS leverage data mining, machine learning, and natural language processing to present valuable information to human decision makers to aid in the decision making process. There are several types of DSS, including model driven, which uses mathematical and statistical models to analyze data, data-driven, which use large amounts of data to generate insights, and knowledge-driven, which use expert knowledge and rules. Benefits of AI and DSS include improved decision-making, increased efficiency, cost savings, and improved accuracy. A common benefit of AI is its ability to come through large data rates with great efficiency and accuracy. Therefore, when used in a DSS, this can lead to faster, cheaper, and better decisions. Pitfalls of AI and DSS include a lack of human judgment, data quality issues, and bias. Though AI mimics human behavior, its reasoning can lack nuance needed to make effective decisions. Additionally, the algorithm's recommendations are only as good as the data they are trained on. Therefore, when trained on inaccurate or biased data, their recommendations can be inaccurate and biased. Real-world examples of AI and DSS include Siri, IBM's Watson, and Tesla's Autopilot. Continuing on, machine learning and data analytics have transformed how organizations handle and use data. ML involves training machines to learn and make predictions from the data it is given so that the AI system can learn and improve performance. DA uses statistical and mathematical techniques to analyze and uncover patterns and relationships in the data it is given to aid in decision making. ML algorithms include supervised, unsupervised, and reinforcement learning. Supervised learning is where data is labeled and outputs are known, while unsupervised learning occurs when data is unlabeled, outputs are unknown, and the goal is to find patterns and relationships. Lastly, reinforcement learning occurs when AI machines are trained to make decisions based on feedback from the environment they are in. In learning about ML and DA, I learned that linear and logistic regression are supervised ML algorithms. Linear regression is a predictive modeling technique to model the relationship between a quantitative outcome and one or more predictors, while logistic regression is a classification technique to predict a binary outcome, such as whether something will happen. Like AI and DSS, benefits of ML and DA include increased efficiency, cost savings, and improved accuracy. Despite the benefits, as noted in AI and DSS, limitations of ML and DA include lack of human judgment, data quality issues, and bias. Organizations use ML and DA to predict sales revenue, cost, and demand. Additionally, they are used for comparisons such as determining if a transaction is fraudulent. Moving on to expert systems, they are a form of DSS and are therefore AI applications that assist in the task of decision making. However, unlike DSS, they hold an information base on a particular domain and are given a set of rules to conduct knowledge representation, reasoning, and natural language processing to recommend a best decision to human decision makers. Types of ES include rule-based, where if-then rules represent knowledge, model-based, where mathematical models are used to represent knowledge, and case-based, where previously solved cases are used to represent knowledge. Again, very similar to AI DSS and MLNDA, benefits of ES include improved decision-making accuracy, increased efficiency, and cost savings. Additionally, limitations include a limited scope or domain, a lack of human judgment, and data quality issues. Lastly, real-world use cases of ES include diagnostic and treatment in the medical field, fraud detection for banking transactions, quality control in manufacturing, and customer service applications. I further realized this week you cannot have a conversation on AI without talking about ethics. Ethical considerations surrounding AI and DSS usage include privacy and security, transparency and accountability, and bias. As I have highlighted on earlier slides, a main benefit of AI and DSS is its ability to analyze vast amounts of data to aid in or conduct decision making. However, this benefit creates a dichotomy in that the citizens have an inherent right to privacy, and when personal data is not secured properly, it can be lost. Regarding bias, AI and DSS must be trained on data, and that data is often derived from human beings who themselves are biased. Furthermore, when algorithms are made without transparency in mind, they lead to distrust, and due to AI's novelty, it can be unclear if accountability falls onto the developers, users, or governmental bodies when systems inject harmful outcomes into society. Real-world use cases where ethics weigh heavily include facial recognition technology, employment decisions, criminal justice decisions, and healthcare decisions. Additionally, another example which highlights DSS limitations related to ethical concerns was Amazon's automated hiring system, which was scrapped in 2017 despite improving efficiency in the hiring process due to its training data leading to discriminatory outcomes. Throughout the week, I learned that best practices on designing and implementing AI and DSS include accurate planning and designing, data collection and pre-processing, evaluation and testing, and deployment and maintenance. These best practices described on the slide can be achieved by leveraging a strategic ethical framework to capture the benefits and mitigate the pitfalls surrounding ethical concerns of AI and DSS. As the week went on, I found myself reflecting on past lessons in information systems courses at UMGC. What I realized was that the National Institute of Standards and Technology's Secure Software Development Framework and AI Risk Management Framework align with the best practices I learned this week in designing and implementing AI and DSS. For example, as shown on the screen, this AI RMF uses the functions of govern, map, measure, and manage to create organizational policies on what right looks like on AI usage, and then map, measure, and manage AI to ensure it is trained correctly, biases removed, and the system output can be trusted. By utilizing the SSDF and AI RMF in a hybrid and iterative approach, organizations can design and use AI and DSS with best practices in mind to gain their benefits while mitigating their pitfalls. In doing so, real-world use cases including diagnosis and treatment in the medical field, fraud detection for banking transactions, quality control in manufacturing, and customer service applications can be achieved. To conclude on the lessons I learned this week, I analyzed two case studies. Unlike its hiring system, Amazon's recommendation system highlights the purpose of AI and DSS. Amazon is a massive company with millions of customers, and therefore using human labor to analyze customer behavior to make decisions is not practical. Instead, Amazon used machine learning algorithms to analyze customer data in real time and provide tailored product recommendations. This use of AI and DSS has improved customer engagement and sales and contributes roughly 35% of Amazon's annual revenue. To mitigate potential pitfalls, users sign usage agreements to register with Amazon, and data collection is scoped to individual shopping behavior, which has led to a positive public response and did not feel intrusive. The other case study was an unsuccessful usage of AI machine learning in the form of Microsoft's Thinking About You, or TAY, chatbot on Twitter. TAY leveraged natural language processing, feedback loops, and pattern recognition, which are all forms of machine learning, to interact with users on Twitter. Its intended purpose was to serve as a human-like friend while learning to become smarter. However, other Twitter users communicated racist, biased, and derogatory messages to TAY, who responded by tweeting those same sentiments out to the public. Ultimately, Microsoft had to remove TAY from Twitter due to these issues. Throughout this week, I learned how AI, DSS, ML, and ES work together to improve decision making across various industries and use cases. Integrating AI removes the human bottleneck, while DSS and ES support decision makers by leveraging ML and data analytics. Across all topics this week, the benefits consistently showed improved decision making, increased efficiency, cost savings, and enhanced accuracy, while the limitations were data quality issues, bias, lack of human judgment, and transparency challenges. If not mitigated, the pitfalls in the algorithms lead to biased systems and can harm society. As the week went on, I began realizing that the best practices of planning and design, data collection and pre-processing, evaluation and testing, and deployment and maintenance could be paired with ethical frameworks like NIST AI RMF and SSDF to build and use trustworthy, transparent, and effective AI and DSS. Finally, this conclusion was further solidified when studying the disparity in the two case studies between Amazon's successful recommendation system and Microsoft's biased and discriminatory chatbot. Therefore, my final takeaway is that AI and DSS have enormous potential to improve decision making, but their success depends on responsible design, ethical governance, and continuous monitoring. Lastly, shown on the screen are the references I used both for my slides and my talking notes. This concludes my presentation. Thank you.